Hi, my name is Iris Perry, and this is my video presentation from Project 1 for my CSCI331VA Operating Systems class. Um, so this is the interface for the project. It has the string or the create and destroy function declarations in it. And then the project was about comparing two versions of PCBs to see which one is actually faster. Because in the book, it stated that the version that doesn't use dynamically allocated memory would be faster because of it doesn't use dynamically allocated memory because it takes a while. So this is version one that does use dynamically allocated memory, which is a linked list, or in this case, we use an array list. Or use an array list. Um, so this first version of PCB entry has two fields, an int that holds the index of the parent, and then an array list that holds the indexes of the children. Um, then you have the constructor for the class, and then a simple toString method. And then this is the PCB linked list class that implements PCBS. You have the constructor for the class, and then this is the create method. If the PCB at that index that you put into this function is null, then you put that it returns that there isn't a parent process. And then right here, we check to see if there's an empty spot for the process that you're trying to add into the PCB. And if there isn't an empty spot, then we return that there's no space for another child process. And then here you create the child process and add it to P's children, and then you return null if it was created successfully. You add it to the array list. So this is a destroy method. If the process doesn't exist, it doesn't do anything and will return null. And then after this, you recursively go through each child of P and destroy it, which is we don't destroy the main process that we have, we're destroying the children of it. The main process of it, process 0, never gets removed. Um, and then a simple toString method, and I had a main function to test this one. This is the version without the linked list, the PCB entry version. It has 4 fields as we were required. Parent, first child, younger sibling, and older sibling. And then a simple toString method. And then this is the PCB no linked list class. You have the constructor. And then for the create function, this right here is basically the same as the other one. And then here we create the children. And with this one, instead of them just straight up being put into an array list, we implemented it with a sibling relationship. So you have to set the first child to be the new entry, or the new entry to be the first child. Or if the process already has children, then you have to set the younger sibling and the older sibling for that. It's a sibling relationship instead of a linked list relationship. And then we turn null if everything was right. And then this is the destroy method. The first part is the same. It doesn't exist. And then we find the index of P's first child. Then we recursively go through all of the children and destroy them. And then we have the toString method. And then I had a main function to test this. And then now we have the test class, which has the main function that we're actually using in it. We create, depending on which version is called, we create either a linked list PCB or a no linked list PCB with a maximum of 100. And then the start time is in the current milliseconds. And then we create several processes and destroy them and loop through this. And then you have the end time, and then you return the end minus the start, which gives you the total time that it took it to run. And then you have the main function right here. I ran the loops 1,000,000 times, and then printed out the difference, which I will run right now. And here we have version 1 took 154 milliseconds, version 2 took 65 milliseconds, and version 1 is 89 milliseconds slower than version 2. And that's it. That's my video presentation. Thank you.